So hello class, this is Mr. Sumingo. It's for Monday's homework. I have how can I say this? I have a new way of doing these notes with a video. Maybe it's helpful to see me teaching, I don't know. The thing is I don't even get to see a video, so I don't know how I look like, so hopefully this works. I'm going to finish up the notes from today. So the one that we talked about was the Remainder Theorem. And this is where we left off on. This is example 6, and the reason why I didn't do this one is I think it's simple enough that you guys understand. But essentially the remainder theorem says that if you divide by x minus k and you plug in k or some number, you'll get the remainder. Or to make a long story short, whenever I plug in this number in synthetic division, I will get a remainder. It's very simple. So for example, I'm going to start with remainder theorem and see how it says it wants that x equals negative 2. So the very first thing is I'm going to put this negative 2 inside a box from today. And I'll put in the coefficients. So I have a 3, I have an 8, I have a 5, I have a negative 7. And again, if I'm going too fast, you could press pause or slow it down or fast forward, whatever. And the reason why it's 3, 8, 5, negative 7 are all the coefficients. And they're also, you notice that's x to the third, x squared, x, and no x. So I'm not missing anything. The steps of synthetic division are I will drop the first one. And then now I will multiply. Negative 2 times 3 is negative 6. And add 8 plus a negative 6 is 2. Multiply negative 2 times 2 is negative 4. And add 5 plus negative 4 is 1. Multiply negative 2 times 1 is negative 2. And negative 7 plus negative 2 is negative 9. So all the remainder theorem says is that if you do synthetic division with a number, the last number that you get is the remainder. So it's a lame theorem, and again, like I can't believe somebody got credit for this. But if you put in a number and you evaluate it, the answer or the last number you get is the remainder. So the remainder of 3x to the third plus 8x squared plus 5x minus 7 divided by x plus 2, I'll get negative 9. Moving on. The factor theorem we did today in class. Remember, we take the opposite. Remember, this is positive 2, this is negative 3. So I will take the opposite and plug them in, and if I get a 0, I will get, if I plug in a 2 and negative 3 and I get a 0, I know that they're factors. Okay. So moving on, the rational zero test. And I'm telling you all these rules and all these theorems because they're going to go logically, but for now you're just going to follow along, and essentially you're just going to take my word for it. Okay. So the rational zero test tells me what are all the possible zeros and what are all the possible factors. All the possible factors are going to be the fraction p over q, where p is going to be the coefficient, the factors of the coefficient. Let me see if I can highlight this. Factors of the coefficient of the last term. And the q will be the factors of the coefficient of the first term. And it accidentally highlighted everything. Well, that's just great. Anyways. So all the possible factors are p over q, where p is the factors of the last term and q is the factors of the first term. Might not make sense, so let me do an example. Example number 8 in your notes, N3. It says find all the zeros and linear factors. Well, I know if I want to find all the zeros or all the possible zeros, let's use the rational zero. Let's do the rational zero. The rational zero test. P, remember, stands up for all the factors of the last term. So what are all the factors of 3? There's 1, there's 3. Q, remember, is all the factors of the first term. So I see I have 2. What are all the factors of 2? Well, there's 1, and there's 2. So I'm going to find what are all the possible factors, okay? So which is P over Q. So the first one I could do, let me use another color to make you understand. If it's p over q, the first one that it could possibly be is 1 over 1. And what's 1 over 1? 1. Okay. Then I could do 1 over, dang it. I could do 1 over 2. Right? 1 over 1, 1 over 2 is another possibility. Then I'll move on to the next p, which is 3. 3 divided by 1, which is 3. And 3 over 2, which is 3. So what I found, what the rational zero test is and what makes it so special is that of these 4 numbers, some of them may be possible zeros, some of them may be possible answers, and some of them are not. But I know it has to be contained within these four. It can't be anything outside of these four. Either none of these four are the answers, or all four of them, but nothing outside of these four numbers will be the answer. So let's do this. What I'm going to do is I'm going to do synthetic division. I'll start with 1. And do you see how all the numbers are accounted for? I have x to the third, x squared, regular x, no x. Sorry, no x. So let's put in 2, 3, negative 8, and 3. Okay, so far? So just like we did in the last one, I'll drop this 2, multiply, 1 times 2 is 2. 3 plus 2 is 5. 1 times 5 is 5. Negative 8 plus 5 is negative 3. 1 times negative 3 is negative 3. And 3 plus negative 3 is 0. Because I have a 0 remainder, okay, because when I plugged in the number, I got no remainder, that tells me that 1 is a 0. So I don't know how I'm going to write this. Let's just say zeros. One of them is 1. Because remember the question asked for what are all the zeros and linear factors? So one of the zeros has to be 1, and one of the linear factors has to be, by the logic of this, is x minus 1. Okay. So now let's try 1/2. So you can sort of see where I'm going with this. I'm going to have to do this for all 4 numbers. Okay. So same thing, 2, 3, negative 8, and 3. I'm sorry, this is messy. But I'll take the 2 and drop it. 2 times half is 1. 3 plus 1 is 4. Half times 4 is 2. Negative 8 times 2 is negative 6. Negative 6 times half is negative 3. And ho, 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 3 plus negative 3 is 0. So yet again, I have another 0, half, and I have another factor, which in this case I will call it 2x minus 1. Now let me erase this. Oops. Well, let me just erase the whole thing then. I know there's an easier way to do this, but sorry. Alright. Next one was 3. So let's try 3. 2, 3, negative 8, 3. I'll drop the first one. Multiply. 3 plus 6 is 9. 9 times 3 is 27. Negative 8 plus 27 is 19. And then 3 times 19 is 57. By remainder theorem, the remainder is 60. I do not get a 0, so 3 is not a 0 and not a linear factor. Okay. Last one, 3 over 2, so to make this quick, let's just do this. 3 over 2, 2. So we're going to get rid of this for now. We don't care about this. Okay. 2, 3, negative 8, and 3. So I drop the 2. I multiply 3 halves times 2 is 3. 3 plus 3 is 6. 6 times 3 halves. Well, I know some of you don't like fractions, but if I do 6 times 3 halves, 3 times 6 is 18, and then 18 divided by 2 is 9. Negative 8 plus 9 is 1. 1 plus times 3 over 2 is 3 over 2. Some of you don't know how to add fractions. Some of you may not know 3 times plus 3 over 2. So remember, 6 is the same, or 3 is the same thing as 6 over 2. So instead of saying 3 plus 3 over 2, it's the same thing as 6 over 2 plus 3 over 2, which is 9 over 2. Since this is not 0, that means 3 over 2 is also not a 0 and not a linear factor. So all the zeros we found are 1, I know I erased it, 1.5, and my linear factors are x minus 1 and 2x minus 1. So what this tells me is that these are all the zeros and linear factors. There has to be more factors, but these are the only ones that are linear, so this is my answer. Yeah? Okay, moving on. Let's try another example. It says find all zeros and linear factors of this problem. And you already know you don't like it because there's a fraction here. Okay. So let's do P over Q again. Okay. Where P is all the factors of the last term. What are all the factors of 9? What are the things that multiply to give me 9? Well, there's 1 and 9, 3 times 3, and those are all the factors of 9. Q, the first, the factors of the first term, there's an invisible 1 here. What are all the factors of 1? Just 1. So 1 divided by 1, 3 divided by 1, 9 divided by 1. The 3 possible factors are 1, 3, and 9. So it could be none of these, all of these, maybe one of them, two of them, but it can't be outside of these 3. So let's try 1. You'll notice in this polynomial, though, is that you see there's some missing x's. I don't have x to the third. I don't have regular x, so I'm going to have to put in some zeros. So I got 1, I got a 0, I got a negative 25 over 4, I've got another 0, and I've got 9. Okay. Drop the first one. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Again, we're dealing with fractions here. Some of you may not like this. I could rewrite 1, and I'll do it in another color. 1 is the same thing as 4 over 4, correct? So if I add negative 25 over 4 plus 4 over 4, would you agree that I get negative 21 over 4? 1 times negative 21 over 4 is negative 21 over 4. 0 plus negative 21 over 4 is negative 21 over 4. Running out of breath. Negative 21 over 4 times 1 is negative 21 over 4. Some of you may not know how to add 9 and negative 21 over 4. So I'll use another color again. 9 is the same thing, to get a common denominator, is the same thing as 36 over 4. So 36 plus a negative 21 is 15 over 4. Which is not 0, which means 1 is not a 0 and not a linear factor. Okay, for sake of time, I'm going to stop there. You could try 3 and 9, and I think if I did my corrections right, I don't think any of them work either. I could be wrong. But in your notes, can you try 3 and 9? And we'll try this out tomorrow. Answer the questions, the 4 questions below to get credit for homework, and I'll see y'all in class. Take care.